So in continuation with the Juran's trilogy in the video 1 of module 2, I am extending further in the video 2 about the Juran trilogy. So here further we'll see purpose of specification and tolerance. Why we need specification and tolerance. So specification, it tells about the detailed description of design, materials, dimensions, performance requirements that a product must be met inside the organization. So the what is the purpose of specification is to meet the customer expectations and regulatory requirements. So to provide a standard for manufacturing inspection and quality control, facilitate communication between designer, manufacturer and inspector. Fourth is tolerance, what tolerance you are going to maintain inside the organization. Tolerance or permissible limit of variation in the physical dimensions or performance characteristics, means where the tolerance must be given, that it be on the upper side or lower side, you are supposed to define correctly. So further, account for unavoidable variations in manufacturing processes. So if there is any variations, that it can be minimized. Balance cost and functionality by preventing overly strict requirements. So what all we do, we have to balance the cost and also functionality must happen in the minimum time. So there must be a strict requirement as per the plan. Further, compatibility and interchangeability of components must be ensured for better output. Otherwise it is difficult to maintain the quality of the product. So by maintaining the purpose for specification and tolerance, so this part of quality, it is maintained inside the organization. Otherwise it is difficult to achieve. So if you don't set specification properly, or if you are careless in setting the specification limits, so what all it happens, we'll see. Overly tight specification increases production cost due to higher rejection rates and need for precision requirements happens. Causes for unnecessary stress on manufacturing process. May lead to supply chain disruption due to unavailability of capable suppliers. So if you give tight specification, higher rejection rates are going to happen. In that case, sophisticated equipment is needed at the workplace. So we expect the precision to be present at the workplace, so that the production cost mustn't be increased. So if you keep tight tolerance, unnecessary stress will be happening on the manufacturing process. This may lead to supply chain disruption due to unavailability of capable suppliers. So timely delivery of components will get lagged. So there will be unavailability of capable suppliers. If it is low specification, what happens? So compromises product quality, performance and customer satisfaction, increases risk of component mismatch and assembly issues, may result in higher warranty claims and repeated damage, inconsistency in ambiguous specifications. So if it is low specification, what happens is customer satisfaction may not happen, performance may not be good, increases risk of component mismatch and assembly issues, may result in higher warranty claims and repeated damage, creates confusion and errors in manufacturing and inspection, leads to disputes between between the suppliers and the customers. So here there may be mismatch with the customer and the supplier. So the specification given by the customer may be one, the thing which is followed may be another one. So overly loose and overly tight specifications in the specification limits, it will be once again a obstruction or time waste to match the customer requirement and go ahead. Setting realistic tolerances. So if overly tight or overly loose cannot be maintained, then you have to go with the realistic tolerance. So realistic tolerance based on internal function and performance of the product happens. So functional requirement is satisfied, manufacturing capabilities are going to be happening with the right tolerance. So cost quality balance is going to happen. Standardization of the equipment will be there. They are going to use industry standards where applicable to simplify production and reduce the cost. Risk assessment evaluate the impact of tolerance deviations on product performance and safety. So like this, if you do realistic tolerance, all the four parameters what all it is defined here, you'll be able to take into control. So by doing realistic tolerance, you'll be able to work without stress, and the work what all we expect it is going to happen at the right time. So further, if you go with statistic tolerancing, so what is statistical? What is statistical tolerancing is, we are going to use statistical method to define tolerance based on distribution of process variations rather than assuming worst case scenario. So what you are going to do in statistics tolerance is tolerance stack up. So this occurs when multiple components with individual tolerance are assembled, leading to cumulative variations. So statistical tolerancing reduces take-up effects by considering variation distributions. So statistical tolerancing helps to avoid too much variation. Worst case versus statistical approach. Worst case assumes all variation at the extreme limit simultaneously. Statistical approach tells about probability distribution to predict likelihood of variation stack up. So like this, worst case and the statistical approach helps to take into control of the various products. So what are these applications? The statistics tolerancing is, it is used in assembly where multiple components interact. Reduces cost by avoiding unnecessary tight tolerance. So like this, statistical tolerancing, it is helpful in the industry. What is the statistical theorem? Statistical theorem states that distribution of the sum of a large number of independent random variables approaches a normal distribution regardless of the original distribution. So the central control limit tells that how the variation must be. So what are all the rejection parts? So what is the relevance of tolerancing is process variations are predicted in a process by analyzing individual components. So tolerance designing is one which is going to facilitate calculations of realistic tolerance based on unexpected distribution of variation. So by tolerancing, we will be able to accept or check out how the machining is happening and how the variations must be controlled, whether the lot must be selected or accepted within the specific control limit. Precision, reproducibility and accuracy are the three parts. What is precision, reproducibility and accuracy, we'll see. So in the precision, it is how much repetitions you are going to get for the process carried out for the different components, or we can expect consistency to be present in all the components when we produce. So here what we expect is repeatability of the process or instrument. It does not necessarily imply accuracy. We don't want accuracy, but we need precision here. So what all the components we want to produce, it will be produced again and again. If you tell reproducibility, it is the consistent result across the different operator, instruments or location. So the results what all we get, not only with one operator, all the operators must be able to get the same output based on the instruments what are they do or location. Sometimes based on the locations also there may be variation, but it has to be taken care. So what about accuracy? So here accuracy is to degree which a measurement or result matches the true or intended value. So here we need correctness of a result. So whenever we do the process on the component, the process can be precise but inaccurate if it is inconsistently produces results deviating from the true value. So like this, when we count accuracy, we need accuracy at some time, we need precision also. So accuracy and precision are the two parts where we expect in an organization for the successful production. So when we see that if there is any deviation, the particular process must be corrected, the particular machine maintenance must be done. So every time you have to go with the measurement so that it is going to give accurate value. So without a precision, reproducibility and accuracy, we cannot expect the value of the product to be right product to be produced in the organization. These three parameters must be taken care to maximum extent.